7th grade math, test 5, study guide. Problem number 1 says, in 8 minutes you can text 304 words. How many words can you text in 10.5 minutes? Well, they give us a rate of 304 words per 8 minutes, and generally speaking, we want to put time on the bottom, right? So 304 words per 8 minutes means over 8 minutes. And they say how many words, so I got to keep words on top if I already have words on top, correct? So how many words would it be, or X words, because we use a variable for a missing number, a missing value, would it be for 10.5 minutes or 10.5 minutes? So I got words on top, minutes on the bottom, minutes on the bottom. Now I can cross multiply and divide because that's what we do for all proportions, cross multiply and divide, correct? Okay, so I go 304 times 10.5, and on this side 8 times x, and of course it doesn't matter if these are switched, right? As long as my 8 goes with my x and these two go together. When I multiply 304 times 10.5, I'll show the work over here if you guys need any help with that. 304 times 10.5, okay, pretend there are no decimals, add your decimals later. And then divide both sides by 8. I'll show the work over here if you need that, and of course I ran out of space, so I continue my subtracting on the side over here. So check that and pause that if you did this already and you didn't get the same answer as me. And then we get 399, so 399 words in 10.5 minutes. Number 2 says, a car traveled at a constant speed for 99 miles. So constant speed means we have a unit right there. Okay. On 5.5 gallons of gas. What is the unit rate? Alright, so if it's 99 miles per 5.5 gallons, we'll put the gallons on the bottom. And then we will divide in and out. Remember, we have to clear the decimal. So the decimal's here at the end, so you got to move it over one time and put it at top. So now it's like multiplying 990 by 55. And I have to know where to start. 55 doesn't go into 9, it goes into 99, so I got to start right here. As I'm dividing this, I end up getting 18 exactly. And remember, I put miles on top, so it's 18 miles per gallon. Now, you could put 5.5 on top, but it wouldn't really make sense because gallons decides how far you go, even though mathematically we can do it the other way around. So you always hear on TV, MPG, miles per gallon. Gallon goes on the bottom, just like time goes on the bottom. Okay. So for 3, it says there are 30 boys and 70 girls in a room. What is the ratio of girls to boys? So they say 30 boys to 70 girls, but then they ask us what's the ratio of girls to boys. So we got to put it in the order of the question. Let me repeat that. You have to put it in the order of the question. So they present it to us boys to girls. We got to flip it around because they ask us about girls to boys. They don't always do that. You just have to read the question and see what they want. So we put it in the right order. We do our factor trees, cross out our ones, and we see there's a ratio of 7 to 3. It could be written 7/3, 7 over 3. It could be written as the words 7, 2, T-O, 7, 2, 3. It's all the same thing. Number 4 says the table below is proportional, which means all the ratios are equivalent. So it says how many grams of raisins are there for each gram of peanuts. So since they said peanuts second, that's going to go on the bottom. Now normally, if we had to write an equation for this or find the unit rate, we always put the second one or the y on top, right? But this is a special question. And I gave you a hint because I put it in bold. And because they could change the order of this on you, right? They could say how many grams of raisins for each gram of peanuts, or they could say how many grams of peanuts for each grams of raisins. So for this special problem, you're going to read the order, and whatever they say second, that goes on the bottom. So just pick one of these points here and just put the peanuts on the bottom this time. And on the next test, when I switch it and I say raisin second, then you put the raisins on the bottom. So just read the directions, see which goes on the bottom. Since they say peanuts second, peanuts goes down. I'll pick any of these points because they're all going to be the same when I put raisins over peanuts. So I'll pick 1.4 over 26, use my factor trees, cross out my 1s, and I get 2/13 grams of peanuts. Look in our answers, we see that we don't have to convert that to a decimal, so as long as my fraction is reduced, as long as I cross out my 1s, I'm good. So for number 5, they say 3 different companies all sell shirts. Company A, they sell $80 for 4 shirts. So remember, money on top, right? We divide in and out, that means $20 a shirt. Company B, they say $190 for 10 shirts, okay? Money on top, divide in and out. Or if you remember the shortcut for that, you can just move the decimal one time. That's how we divide by 10 the quick way, right? Move the decimal one time. $19 per shirt. So company A is $20 a shirt. Company B is $19 a shirt. Company C says 5 shirts cost $105. Again, money on top, even though they didn't give it that way to me in the problem. So I divide in and out. I get 21 there, $21 per shirt. Question says, which company has the lowest unit price? Well, these guys are 21, these are 19, these are 20, so it looks like company B is the best price. Problem 6 says, we're going to prime factorize 27. So remember, we check 2, 3, 5, 7. That's the minimum, right? And 2 doesn't go into it because it's not even. 3 goes into it because 2 plus 7 is 9. 3 goes into 9, so 3 also has to go into 27. 3 times 9 is 27. Keep breaking it down. 3 is prime, so I drop it down. 9 is not prime, it's composite. 3 times 3 is 9. Now they're all prime. That's my prime factorization. 7 says 245 over 175. We have to simplify this fraction. So we're going to do our factor trees. Again, we're going to check 2, 3, 5, 7, right? Keep breaking it down until we can't break it down anymore. That's what the prime factorization for 245 looks like. And this is what 175 looks like. So I simply put 245. Always use your last line, right? Don't use anything from any lines in the middle. Use your last line or your prime factorization, okay? So this is 245, 5 times 7 times 7. This is 175, 5 times 5 times 7. Cross out your 1s. 7 over 5 is a reduced fraction for 245 over 175. It is simplified. Same value, just looks different, even though it's the same exact fraction. Just now it's simplified. Okay, so number 8 says it looks like we have a complex fraction there, and we have 11 over 11 thirds, and you see this line's a tiny bit bigger, so that's where the division symbol goes, okay? So you see here the division symbol is going to go right there. So I'll make that into a fraction, 11 into a fraction. How do I divide fractions? I multiply by reciprocal. Multiply by the reciprocal, I flip the second one, never flip the first. Factor trees, they're all prime, except for 1, but well, 1 you can't break down. Cross out your 1s and simplify, and that simplifies down to 3. Next, problem 9 says simplify, same kind of problem, but this time the longer line's on the bottom. So that means this whole thing is like one fraction right there, okay? So I got 8/5 divided by 4, because the longer line's there. I make that 4 into a fraction, 4 over 1. How do I divide fractions? I multiply by reciprocal. Then I do my factor trees and cross out my 1s. There's a 2. There's another 2. Nothing left to cross out. 2 times 1 on top, 5 on the bottom. 2/5 is that fraction simplified. 10 says Larry can swim 2/3 miles in 1/2 hours. 2/3 miles in 1/2 hours means 2/3 miles. I'm sorry, it's 1/5 hour, excuse me. 2/3 miles in 1/5 hour. So, 2/3 mile in 1/5 hour means 2/3 mile over 1/5 hour. And over means division. All fractions are division problems, right? All division problems can be written as fractions. So then, like we talked about before, how do we multiply fractions? Divide fractions, we multiply by reciprocal. And I would get here, factor trees, cross out my 1. There's nothing to cross out, so 10/3 is already simplified. That's a simplified answer. But because this is a word problem, they converted it, so I divide in and out, and I get 3 1/3 miles per hour. Pause the video if you need to do that, okay? Alright, number 10. Alright, so 10 says this. Same type of problem. 11. Sorry, I'm tired right now. So 11 says an animal walks 7.5 miles in 1.5 hours. That means 7.5 miles over 1.5 hours, which means 7.5 divided by 1.5. Make them both a fraction. We start at the bottom. First we multiply. 2 times 7 is 14. Then we add 1. That's where I get the 15. Keep the same denominator over 2. Same thing here. 2 times 1 is 2. Add 1 is 3. 3 over 2. How do we divide fractions? We just did that 2 times in a row. We multiply by reciprocal. Factorize. Cross out your 1's. There's a 2 on top and bottom. There's a 3 on top and bottom. What's left is a 5 on top. 5 miles per hour. Miles is on top, so it's miles per hour. When we divide like that, it's the bottom is always a unit rate. How much per 1? Okay. 12, we talk about Deanne. Deanne had $9 for 3 yards. Well, that means $3 a yard, right? We divide money on top. Jesse is $24 for 2 1/5 yards. So look how I write that. I put money on top. Then I write it as a division problem. I convert 2 2/5 into a fraction. Pause this video if I'm going too fast and do it. And then I multiply by reciprocal. And then from there, again, factor trees, cross out your 1's. Let's see what that looks like. Factor trees, cross out your 1's. Okay. I got a 2 up here, a 2 down here, 2 up here, 2 down here, a 3 up here, a 3 down here. That's all that's left. So 10 means $10 per hour, because remember we had money on top, $10 per yard. Money on top, yards on the bottom. So next we have Deborah. Deborah is doing $6 for 1 1/3 yards. That means $6 over 1 1/3 yards. This is another way to say over. You can write it this way, which is division. So you're going to make the 1 1/3 into a fraction. Again, multiply 3 times 1 and then add 1 to get 4/3. Keep the same bottom number. Multiply by reciprocal. Factor trees, cross out your 1's. I got a 2 up top, 2 at the bottom. I can't cross those 3's out, right? Because you have to have 1 up and 1 down. That would make it a 1. Both on top makes it a 9. So I got 9 over 2. Since this is a word problem, I would divide in and out. Put my decimal. And 4.5 means $4.50 per yard. Just put my 0 there, shouldn't I? All right. Now, I know that... so we talked about Deanne doing $3 a yard. Jesse was $10 a yard. Deborah was $4.50 a yard. The question is, how many of them paid the same unit rate? None of them paid the same unit rate. They all had different prices that they paid. So 13 says, it looks like we have a table for 13. And 13 says, select a statement that is true for this table. So I'm going to take this table here. And now remember, unless it's those one tricky problem, like the tricky problem that says, the peanuts where they change the order sometimes, but not sometimes. Other than that, we always put the bottom over the top, okay? Or the second one over the top, okay? Except for that little tricky one that you see right there. So I'm going to put cows over horses. Now I don't have to do it this way. It's going to be the same as when we graph it. So I put cows over horses. And I go in and out. That means 7.5 cows per horse. Next one, you see this point right here? 1 and 7.5. I'll put cows over horses. I'll just keep it all the same. Cows over horses is 7.5. That means 7.5. 7.5 cows for every horse. And I take the last point. Last point was 4 over 30. But like I said, we always want to put this over this. That's going to be the same for when we're graphing, so we get used to that, right? Except for that one weird question where it's bold to give you a hint. So then I put 30 over 4, and I get 7.5. Those are all the same. That means it's proportional. When you get the same ratio every time, it's proportional. Number 14, we just have to solve this proportion. So we talked about this a million times in class. Every time we solve proportions, we cross multiply and divide by the coefficient, the number in front of x. Okay, and if I check that to see if it can be reduced, it can't. It's not a word problem, so as long as it is simplified, I don't need to convert it to a mixed number. 15 says we have, it asks us which proportion could be used to solve this word problem. The word problem says this. It says 34 people walked, so I got 34 people, through the gate in 25 seconds. So there's 25 seconds. If 50 seconds pass, so 50 seconds, how many people walk through? So when you set this up, you want to keep people with people and seconds with seconds. Now, if it was a unit rate question or if you're graphing, always time goes on the bottom, right? But we can mess that up for proportion as long as we mess it up on both sides. But in general, just keep time on the bottom, money on top, right? That'll help you with most of your word problems. So I put 34 over here, over 24 seconds. This would work. So if I find this, I'll pick it. But now, if this would work, I could also flip these two around. So it would work like this, right? I can put this on this side and this on this side. It's the same thing. So this could work too. Now, if I wanted to mess up my order, if I wanted to put time on top, switch this, that's okay as long as I mess it up over here too, as long as I put time on top over here. So if I have seconds with seconds and people with people, and as long as I keep the 25 with the 34, this could be an answer too. And of course, we can take these two and switch these two around. So all four of these could work. So if we look at A is 25. 25 is seconds. So they put seconds over people, and then look, they put people over seconds. You can't do that. A can't work. For B, they put 50 seconds over people, and then they put 75. They added some stuff together somehow that we don't have a 75 there. We only add when they say total, right? For C, they have seconds on top, people on the bottom, seconds on top, people on the bottom. That was one of the ones that worked, so that checked out. And D doesn't work because they have seconds on top, then they put seconds on the bottom. That's why that doesn't work. So the answer has to be C for number 15. Number 17 says, 16 says, did I mention I was tired? 16 says the ratio of girls to boys at a concert is 4:7. So they're giving us girls to boys ratio. Then they said, how many girls are there if there's a total of 10,000 people? So they gave us girls to boys, but they're asking us about girls to total. So whatever they ask you about, you have to convert your ratio to that. So we're going to convert girls to boys to girls to total. So there's 4 girls for a total of how many? Out of 4 and 7. So we got to add those two together. Remember, anytime they say total, you're going to add something, right? So I'm going to add those up. I convert 4 sevens to 4 girls to 11 total. So now that I have girls to total, I can answer the question because they asked me girls to total. Girls on top, total on the bottom, girls on top, total on the bottom. So then I go ahead and cross multiply and divide by the coefficient, and you should get about 3,663 girls. If you need help with the division, let me show this to you. Okay, so go ahead and pause the video if you had trouble with the division. Notice that I stopped after tenths because if I'm going to round to the nearest whole person, I wouldn't want part of a person, right? So round to the nearest whole person, then I can go to tenths, and that gives me about 3,636. All right, number 12. What am I talking about? Number 17. 17 says a car traveled 465 miles on 15 gallons. That means 465 miles over 15 gallons. On, in, each means over, right? How many total? Oh, there's that word total again. We're going to have to add something. How many total gallons would be used to travel an additional? So total and additional both are telling me I have to add. How many total gallons would be used to travel an additional 100 miles? So I'm going to add miles to miles. Sometimes, students, you guys, you know how to do this problem, but you add miles to gallons. You got to add miles to miles or gallons to gallons. Okay? So just make sure you're adding the same thing to each other. Now I got miles on top on both, gallons for both on the bottom. That's so they're asking me how many gallons for a total of 565, because that's 465 plus an additional 100. Cross multiply and divide. So I showed the multiplication over here in case you had issue and you didn't know what you did wrong. Hopefully I did it right. Multiply those two, I get 8,475. Divide by the coefficient. I'll show the work for that as well. And notice that when I show the work for the division that I stopped at tenths. Because if I'm rounding to the nearest gallon, let me see, we're on 17. It said round to the nearest whole number. Yeah, that would be gallon because it said how many gallons. So I'm rounding to the nearest gallon. I can go to tenths and round to the nearest. That'd be about 18 gallons. Problem 18 said find a constant rate of change. If they say constant rate of change, that means every y over x will be the same. Okay? So for rate of change, remember, time goes on the bottom, so kind of got to flip it just like we do for graphs. Okay? So I would just take one of the points, put feet over time. Time goes on the bottom. Factor choose, cross out my 1, 3/7 feet per minute. Okay? And you can look in the answer to see that you don't need to convert that to a decimal. I left it as a reduced fraction. Just make sure you simplify it, and you're good. Now, notice I could have used this fraction right here, right? I could have put 3/7 there. That would have been smarter, because that one would have already been reduced. Okay, so, actually, I am wrong. It looks like we do have to convert, because in the answers, yep, Yep, in the answers it converted it to a decimal, so we divide in and out. So that's why I did that here. I continued. This would have been an okay answer is my point, but they wanted decimals, so we keep going to the nearest tenths, the problem said to round to, so we have to go to hundredths to round to the nearest tenths, which would give you about 0.4 feet per minute. Alright, almost done. 19 says, find the constant rate of change. Well, this is a straight line that goes to the origin. That means the constant rate of change, or the unit rate, or what will be known as slope t in the near future, will always be the same for lines that go through the origin. You just take one point and put y over x. So here's a point. My coordinates for that first point are 1, 104. So I take the coordinates, 1, 104. My constant rate of change, what they use for the symbol k, when it's written as slope, they use the symbol m. For now, just know that k means constant rate of change. Put y over x, and I get 104, which stands for 104 miles per hour. If I would have taken any of those points, I still would have got 104 when I simplified the fraction. So the last one says, what do the coordinates 4, 16 mean? Well, it's 4 hours, right? Side to side is the x, and the x-axis is hours, and the y-axis is miles. So it means after 4 hours, it's 416 miles were traveled. Or you could say it this way, 416 miles were traveled in 4 hours. Those are both the same thing. All right, sounds great. I hope that helped you guys out.